Hi everyone, so we're going to start talking about the skeletal system. We're moving on to our next unit here, which is going to be our skeletal system and joints. So let's start here. So as we always do, we're going to start with some functions. So some functions of our skeletal system is support and protection, body movements. So bones and muscles are going to function as a lever, and we can see that here when we're lifting weights. Our humerus and ulna right now are going to be our lever, as our muscles on our humerus bone are going to be using that movement there. Another function is blood cell formation. So hematopoiesis. This is really important because we know that if we lose blood, we need to make new blood. And also that when our blood is no longer functioning very well, we are going to be making new blood cells to replace those. So in our red bone marrow, we're going to produce red blood cells, white blood cells, and platelets. And in our yellow bone marrow, we are going to store fat, and it's inactive for cell formation. So yellow bone marrow just stores fat, where our red bone marrow is going to produce those blood cells. So if we look here, we see some of the structure of our long bones, which is where we're going to see this. So we can see our compact bone, very tight knit, can't really see any divisions. And then we're going to see in here we have our medullary cavity, which is going to store that yellow marrow. So another function here is going to be inorganic salt storage. So 70% is calcium phosphate. So this is going to lead to making our bones very hard and resistant to crushing, which is very, very important as it is our structure of our bodies. And then 30% is going to be a protein called collagen, and that's going to give our bones its strength. So let's take a little bit of a look at bone structure. So we have a couple ways that we can classify bones. So a long bone would be something like our limbs, or for a specific example, our femur. Short bones are wrist bones or even ankle bones. Flat bones are going to be our ribs, or our clavicle could also be classified as a flat bone. Irregular bones are going to be our vertebrae, and sesamoid would be something like our patella. So every bone in our body can be classified by one of these terms: long, short, flat, irregular, or sesamoid. So if we take a look here, we can see A, this would be a long bone. B, this is a short bone. C, this is a flat bone. D, this is irregular. And then E is sesamoid. So this would be our femur. We can see our tarsal, one of our tarsals here. C, for our flat bone, would be a piece of our skull. D is one of our vertebrae, and then our sesamoid bone would be our patella. So let's take a look at some of the different parts of a long bone. So we have an epiphysis or epiphyses, and these are going to be found at the ends of the bones. We have articular cartilage. So this is a hyaline cartilage, and it's going to cover our epiphyses. Our diaphysis is going to be the shaft of the bone, so the long part. Our periosteum covers our diaphysis, and it's going to be made of dense connective tissue. And then we have our medullary cavity, which is going to store our yellow bone marrow. Our endostem, which lines the medullary cavity. Spongy bone, which contains our plates called trabeculae. And then we have compact bone that has a continuous matrix, very, very tight knit together that we saw earlier. So let's take a look at all these different things that we see here. We have our distal epiphysis, our proximal epiphysis. Our diaphysis is this nice long part here. Taking a deeper look, we can see our periosteum. is lining our diaphysis, our yellow bone marrow inside our medullary cavity, our compact bone on all sides of our medullary cavity. Our endosteum is going to line the inside of that cavity. And then we see up here we have spongy bone. So we can see spongy bone over here has a non-continuous matrix, has holes in it, which is going to allow that container of red blood cells or red bone marrow. And then we can also see some articular cartilage right on the end of our epiphyses. We can see some over here as well. And then our last thing is going to be our epiphyseal discs, which is going to allow growth in our bones. And we'll talk about that a little bit later. So let's take a look at our microscopic structure. So we've seen bone tissue under the microscope already. So we know that osteocytes is going to be that bone cell. And they're going to be found in lacunae. So these words should have a kind of ring in your ear. And then all of these, our lacunae, are going to be found around our osteonic canals or our central canals. So osteates are going to communicate with nearby cells called canicula or caniculi. And they're going to tell each other what needs to happen within our bone. So if we take a look, we know that our central canal is kind of just that big hole in the middle. Our lacuna, that's where our osteocytes are going to be located. And if you see all these really, really tiny little dots here, that's going to be our caniculus or caniculae. So as we know, we are born with the bones that we are going to have in our body, but we are born at a very small size. So everything inside our body, including our bones, are going to need to grow and develop. So let's talk about that a little bit. So we have intramembranous bones. So these intramembranous bones, a good example of these are bones of the skull. So these bones have not completely formed yet. So we have connective tissue that is going to turn into bone here. So I'm sure you've heard of soft spots on a baby's skull. These are called fontanelles. And these fontanelles allow that skull to pass through the birth canal. So it kind of allows the skull to move a little bit as it's passing through. And then once we are fully developing, maturing, we're going to see those close up, moving that connective tissue to bone. So if we look, we see some of these bones, our frontal bone here. We can also see some of these fontanelles. So this is one of our soft spots here, made of connective tissue. We can see our suture lines are still made of connective tissue. And our another soft spot, connective tissue here. So once we grow into our full size, we are going to close these fontanelles and create suture lines that connect all of our skull bones together. Another thing that we're going to see is endochondral bones. So an example of this would be our long bones, like our femur, where we're going to see actually hyaline cartilage turn into bone here. So our long bone, we know that we have those discs that we saw earlier, so our epiphyseal discs. Our long bones are going to continue to lengthen while these cartilage cells of our epiphyseal discs are active. So as we grow, as we're growing taller and everything, these discs are going to actually be expanding our bones. And as these discs ossify, so once that happens, we can no longer grow any taller than we already are. So when you've heard before, like, oh, your growth discs are closed, that means that you're no longer growing, that all of these discs had been ossified or became bone. So you can see this epiphyseal disc right here on our long bones. These ones have not yet closed yet, so they're not fully ossified. So this person is still growing. So again, we can see our intramembranous bones are going to be bones of our skull, and then our endochondral bones are going to be our long bones forming here. So just a little timeline that we see. So our 3rd month of prenatal development is we're going to see the ossification of our long bones starting to begin. So our next thing that we're going to see, our 4th month of prenatal development, primary ossification centers appear in our diaphysis of our bones, remember, so that is our shaft. Birth to 5 years, so both of these were before we were even born yet. So birth to 5 years, we're going to see secondary ossification appear. And then at 5 to 12 in females or 5 to 14 in males, ossification is going to rapidly spread and our bones are going to become really, really strong. So at the ending that we're going to see, about 15 to 18 for females, and a range for us to stop growing here is usually about 25 in males and about 23 in females. So we know this happens, males usually go faster, but we see an exponential amount of growth in younger aged children because of this ossification timeline that we see here. So from birth, or from even prenatal development, to all the way up to about the age of, I'm going to say about 16 to 15, all of our growth is going to happen between those years, which makes it crazy to think about all of the, that our bones are going to pretty much fully mature in such a short amount of time. So that's where we're going to end for now. Just talked a little bit about some of our bones, our prenatal development of our bones. If you have any questions, make sure we reach out.